a great honor, in fact, for me to chair the session of our first keynote. Professor Rajkumar Buuya, my fellow Australian from Melbourne. Rajkumar is Redmond Berry Distinguished Professor and Director of the Cloud Computing and Distributed Systems Clouds Lab at the University of Melbourne in Australia. He is also serving as the founding CEO of Manjra-Soft, a spin-off company of the university, which commercializes its innovation in cloud computing. Raj is very productive author. He has authored over 850 publications and 7 textbooks. He is one of the most highly cited authors in computer science and software engineering worldwide. His H index is 140, very impressive, citations close to 110,000. And for that, he has achieved many recognitions and awards by such bodies as Web of Science, Scopus, and others. Raj has served, had served as founding editor-in-chief of IEEE Transactions and Cloud Computing, and currently he is serving as editor-in-chief of Software Practice and Experience. So it's great to have Raj here. His keynote is on Neoteric Frontiers in Cloud and Edge Computing. Please.
So thank you, Jack, for introducing me to the other attendees. So let me thank the conference organizers for inviting me to be part of this event. And of course, our friend Marcin has always been, has always been impressing me or encouraging me to come and attend this conference. I'm definitely looking forward to attend the conference in person in the future. I'd like to thank also Maria as well for actually interacting during this conference organization and clarifying any questions whenever I had. So thank you. Today I will discuss about some of the new advances in cloud and edge computing. So of course, these advances are driven by real-world applications in big data and IoT, and so this is very well fits to the conference focus on computer science and intelligent systems. So this is where these IoT applications are broadly under intelligent systems, intelligent system applications. So here is the brief outline. I will very briefly discuss about different computing paradigms. So bring you to the speed very quickly, very briefly. Then we will take a look at state of the art in cloud and applications. So with that, so brief discussion, then we will move on towards this market-oriented cloud architecture, because when we say cloud computing, we mean computing capabilities, services, and applications delivered to consumers on subscription basis. When you are subscribed to services, you are paying for the services. So therefore, the way services are allocated and delivered, quality to the consumers depends on the price and charge that they're making. So market principles, economic principles plays a very important role here. We'll discuss the architecture, and we will see also a cloud application platform called Anika that helps you to build applications and deploy on cloud, where you can minimize the cost of computation by selecting set of resources that are fits your requirement in terms of quality, in terms of price they are charging or budget willing to pay. So then we will discuss about some of the new trends in IoT. So we will take a look at again in terms of IoT, Internet of Things applications has been around, particularly cloud centric. There is a move towards new computing model like what we call edge computing, especially to support applications that require low latency services, and they are very prominent in healthcare in various areas. So then we'll conclude at the end. So this is the plan. So I will discuss this within 50 minutes and then leave 10 minutes for question answer or interaction that any one would like to have. Okay, so moving with this brief discussion on different waves of computing or computing paradigms, and here is the just a view of timeline from 1960 all the way towards 2020, and then of course next 30 years. What are the prominent drivers of applications and prominent computing technology that supports them? So we all know that in the 60s there were mainframe computers, that is like just one per country. So that was the model. Then came mini computers. So that replaced perhaps mini computers per like one per division. So then client server computing came, the various shared resources across the enterprise. So then, of course, web came 25 years ago as a way of sharing information among few scientists, and that became a commercial or a worldwide success. And we see we are operating our whole life through web, and of course, this conference is made possible through web-hosted services. Then came this cloud computing last 10 years ago, so it's prominently moving towards providing computing as a utility. So rather than buying computing capability, application capability, you can just subscribe to those capabilities and use it and pay for what you consume. So that is the cloud computing model. Then of course this IoT, Internet of Things. So not just standard internet, which is a network of computers, but extending that notion towards Internet of everything. So all the physical elements in the world become part of internet. So when that becomes that, when we achieve that, we will create, we'll end up having much more smarter systems where integration of physical world and the digital world will be more seamless. Then as a result, resources will be used much more efficiently. So this was the goal of Internet of Things, and then accordingly to support the IoT, we now have emergence of what we call fog and its computing environments. So this is all brief. So of course our focus is going to be on primarily cloud and edge computing. So all these advances in computing or computer science in the past heavily driven by big scientific applications where massive amount of data is created and the data need to be analyzed in collaboration or individually by experts around the world, and that was the main driver for many advances in both computing and communication. So but much recently that has shifted towards big population application. So when we think of mobile services, mobile application, especially with IoT sensing devices everywhere used in different purposes. So this shift has occurred where the big population is a major driver for advanced computing. So as a result, you see mobile phones are becoming more and more powerful. Today's mobile phone is probably more powerful than a supercomputer 30-40 years ago. So the capability of supercomputers, 30 years ago, what was we call a fastest supercomputer, but today the same capability you can get it on a mobile phone. So what it means is the shifting from big scientific advances requirement towards this big population, which is a good thing. So this way we can bring benefit of computing to masses. And having just glanced at this cloud computing, so cloud computing essentially allows us to offer subscription-oriented services to end users. So when end users subscribe to this capability, they can subscribe to compute capability, storage capability, application capability, data services. So these are various kinds of services are provided to consumers on subscription basis. And here is the high-level view of how cloud looks like. So one end we have got users from all over the world, and these users want to access this capability, and these capabilities are cloud capabilities which are somewhere in the networks. They don't need to know where physically they're located and how they're managed and so on, low details. Instead, they subscribe to those capabilities and use and pay for what they consume. That means these are metered services. So the usage of capabilities are measured just like electricity. When you consume electricity, there is a meter that measures how much electricity you consume. Accordingly, they charge you. Similarly, in computing, also how much capability you are consuming. Whether it can be that capability can be compute, raw compute capability, or it can be storage capability, or network, or application, or maybe data set. So these are different capabilities. Of course, as consumers, we subscribe to one service provider. That doesn't mean that one service provider does everything for you. So that service provider might in turn be using service from multiple other providers, put them together and deliver to you as a composite service. So we as a consumer subscribe to one provider, then the rest happens automatically in the seamless in the background. So which means when the services are delivered to consumers, the capabilities from multiple locations and multiple vendors are seamlessly integrated and to deliver those capabilities to end users. So that is how the cloud applications are, systems are created. Accordingly, there are many applications of cloud we have today. And many of those are coming from different domains, from scientific domain, from engineering domain. So these are the traditional ones. But what are more popular are these consumer and social network domains. These are very, very popular. So to give an example, like Twitter, we all use for as a micro messaging service. The Twitter is running on a cloud. And you can easily find it out. You can just type twitter.com/Buuya, my own Twitter micro messages. So when the browser is accessing that content, it often shows you below, s3.aws.com. So for example, that is an application. Then of course, these are video conferencing software systems like Zoom or even this WebEx that we are using. So these are the cloud hosted video conferencing services. So why cloud hosted? You can see these compute capabilities are distributed around the world, and then the users like us who are attending the conference today are also distributed. So we have participants from all over the world, and each one of us expect best quick response time. So to deliver this service to us, rather than hosting the whole application on a single place, they use a distributed cloud architecture to deliver this capability. So like this, there are many applications are already, we are using it. So that's what I want to highlight. Cloud is here and very successful, and there are numerous applications already benefiting. And as a result, you can see many other applications that we use regularly, which are supporting mass e-commerce operation and email operation and so on. These are running on cloud. And if you look at what happens on internet per minute, within 60 seconds, for example, millions and millions of users are accessing these capabilities, whether it's a YouTube or a Facebook or a Twitter or so on. You can see these are our applications are delivered through cloud. So cloud success is actually demonstrated, via these applications. So which is a good thing. But as we move forward now, in the new trends, we know that in computing every 2 or 3 years, we get new technology that suddenly come and disturb the architecture, disturb the way services are delivered, because they want to make it more low cost, they want to make it accessible to large number of applications, they want to make it more reliable, more scalable, and all these promises, and they constantly evolve. And so far, cloud architecture was very much driven by what we call virtual machines. So when you rent a capability in a cloud, what you rent is actually a virtual machine. And that notion, one of the challenge or weakness of the virtual machine was that it takes quite a bit of time to spin a new virtual machine. So to reduce that startup cost, startup time, so this concept of microservices came into picture. And microservices are not only for that purpose, but also to to enhance, to rapidly to improve the software engineering. So when you are building up new application capabilities, you want to be able to build very quickly by combining multiple tiny services. And this is made possible through microservices that improves, software systems reliability. So then, of course, this Internet of Things is other driver. So rather than having application running somewhere in the remote place, which is generally high latency. So now this Internet of Things, the devices, sensing devices everywhere, and they don't want to go to cloud. They rather use somewhere in the nearby. So that is changing the architecture. Then also this concept of what we call serverless computing. So rather than having a very tightly coupled systems, we want to make serverless. Then the network that is driving these things, shifting from earlier architectures towards software defined. Then of course we want to provide trustable services in cloud. So can we trust the services? So this is where blockchain comes into picture. Blockchain, normally we think of a technology to support digital coins, currency, but the same blockchain can also be used to create trustable services. And soon I will discuss you about the use of blockchain in delivering healthcare services in edge cloud integrated environment, where you can enhance the trustability of results. Then the new application driver, this AI, Now AI is so popular. This is what we call, you can say, intelligent systems with appropriate machine learning, deep learning techniques that learn by itself and provide intelligent services. And these applications have even more unique workload, requirement. As a result, various companies are even creating AI workload specific microprocessors. So then what to think of higher level programming platforms. So then of course now during last 1.5 year, and we hear a lot about COVID, and then this cloud, for example, played such a significant role that everybody work from home. When you are working from home, obviously you need a computing environment to support it, and whether it's a business or office for working from home, all of this very much driven by cloud technology and network technology. So cloud has played significant amount of role during this COVID-19 pandemic. So you can see as a result, the usage of cloud infrastructure during late 2019 to now, it almost increased by 50% more, whatever it was. So this is a really cloud helping this COVID pandemic, where still the education can go on, business can go on in limited sense. Then of course people health issue and all. So a lot of things are big challenge, but cloud has played a very significant role in this period. Coming to AI, the reason I'm more emphasizing this is that the next I'm going to discuss about architecture and the influence of other requirement on the architecture of cloud and the application. So, and you can see AI is playing a significant role in enabling applications in several scientific, business, and societal domains. And you can see all the way from healthcare towards entertainment system, recommendation system, then this emerging smart vehicles or a driverless car. All these applications, in these applications, AI, cloud will play a significant role to create this intelligent environment. And that means they also, push a lot of demand on these systems. So that is all about, just in brief, and then discussing about some emerging application. Now, move towards this cloud architecture. How do they influence both applications and the technology? So looking at this market-oriented cloud architecture, when we start going deep inside cloud, what are the elements and how do they influence on the service and quality and the price that is charged to consumers, then how the resource can be used efficiently. So at cloud, is first element is a what we call data center or computing infrastructure, which is essentially collection of servers interconnected through special networks, high-speed networks. So this collection of servers interconnected, so perhaps they can be in one or multiple places. So there can be a collection one, let's call it the Melbourne cloud, and there can be a collection of another, so perhaps in Poland cloud, like these different data centers, and these collection are there. And so these servers are not directly rented to consumers. What they are rented is a virtual machine. So when users make a request to cloud, requesting for certain capability, based on their capability, virtual machines are created. So now, given we are running this, WebEx application, so depending upon number of users for this WebEx, for example, if there are n number of users from maybe 100 number of users from Australia, for that request, the cloud environment created one virtual machine, and perhaps that virtual machine is mapped to a physical machine located in Australia. So this way, the request can be served quickly. So on that, so based on request, virtual machines are created. Virtual machines are mapped to physical machine on that application running. So applications like WebEx or any healthcare application, or there's YouTube, there's so many applications running. And these applications, the demand on that application can also vary. Initially, you might, while starting, you might have just 1,000 users, and as time progresses during peak days, peak hours, it might be 10,000 users. So therefore, what do we do? So if you start providing the services using just virtual machine that you created just for 100 users, it won't be able to support with better quality for 1,000 users. So we need to create dynamically extra virtual machine, and these virtual machines are created and expanded. And then, of course, if the users are coming from different regions of the world, then you don't want to do it in one place. Instead, you want to create virtual machine and map it to data center in other place seamlessly. So there is another data center. is used. Then of course this goes on, and then at some point the demand decreases from different places. At that time you also shrink. So reduce the number of resources allocated. So this is what made cloud computing very special. What we call this property called elasticity. You can expand or shrink based on the demand on application running so seamlessly. So which means you can deliver services at at the highest best quality, and also at the best price. That way you can improve the resource efficiency, plus also you can improve the energy efficiency. So you don't want to simply run these systems or servers when you don't need them. So you can dynamically turn on, turn off, and these are all done seamlessly by automated systems. And there also you can how to manage this. It's also part of intelligence system where you can use machine learning techniques to manage the resources better. For example, we have been doing work on that area. This is a recent push, AI-based or machine learning-centric cloud resource management. So, so system, because it's very complex, thousands of servers are there. You can't really use the standard systems and approaches. You need very advanced technique. So that is all in terms of architecture. And you can see here the services are charged. The users are priced based on the quality they're expecting. So therefore, we need to allocate resources in such a way that quality is delivered at lowest possible cost. So this is all conceptual. So which means building software is also very challenging in this environment. So now let me briefly discuss about a cloud application platform called Anika that we developed. So this cloud application platform Anika allows you to build multiple applications in a which can be elastic in nature or a resource computing in nature using different models of programming. So this Anika comes with two key components. The first one is software development kit. The second one is the runtime resource management and scheduling system. This software development kit contains APIs, application programming models, and interfaces for such as thread model, task model, MapReduce. The different models of programming are there. So these models can be used to create applications of different nature. Application can be scientific application, the big data application, IoT applications, or enterprise application. Like the different type of applications can be created using different models of programming. And once you build your application, you can deploy either in a private cloud or a public cloud or multiple clouds in a seamless manner. So this is in brief what Anika is. But when we go deep inside Anika, what does it contain? Essentially, the service-oriented container architecture, wherein we are able to host different programming model services, whether it can be task model, thread model, MapReduce. So the foundation services are extended to support them. So Anika is an extensible system. So tomorrow, let us say you come out with a new idea. So let's say you're working on some special intelligence system, and those systems have a very unique way of expressing that programs. Then existing programming models are not suitable. So you come up with a new idea. You can easily implement that on top of Anika so quickly. So that way, innovation in computer science can also be made possible. And then, of course, as I said, you can deploy on different public clouds or private cloud. This we made possible through by building adapters for different like Azure, Microsoft Azure, or Amazon EC2, and so on. So this Anika software actually, we have been innovating this for last 10, 12 years. So initially we started as a way of supporting simplified bioinformatics application, bioinformatics. Then as we move forward, so we start looking into different applications with the different requirements. So you can see over a period of time, the most recent one is driven by all this AI, deep learning application, and IoT application. Accordingly, we build necessary elements and plugins to support these applications. So this is a good thing about how Anika is evolved. Then at the same time, underlying cloud infrastructure is also changing. And you can see different cloud infrastructure service providers are coming in all the way starting from Microsoft and Amazon and Google, and every year newer industry players are coming in. But each of these industry infrastructure service providers, they come out with their own API, their own interfaces. So if you are building application for them, you may have to build one for this, one for that. It is too much. The cost of software engineering is going to be high. So therefore, we encourage people to use Anika and build application. Then do not worry about the low-level details. So we have built adapter for different type of cloud environments. whether it is Azure or a VMware or Windows or Amazon, or you might create your own private cloud using infrastructure using OpenStack. If you do that, we have Anika that works with all of this. So in seamless manner, the application that is creating an application using Anika doesn't have to worry about any of these low-level details. So this is all seamlessly taken care. And this Anika technology has been used by numerous users worldwide. So let me briefly present one or two, but primarily I'll focus on healthcare application. So today, more and more, people interested in that area. So just briefly to share, Anika is used by China Railways Corporation in China for high-speed train design in timely manner, like rendering operation. Then, for example, in India itself, Indian Space Research Organization called ISRO for satellite image processing. Then in US, Washington State University, so they use Anika for deploying privacy-aware medical data analytics on cloud. So when you're doing medical data analytics, so in medical data that are captured in hospital, so there are some data sets that are sensitive. Such sensitive data you probably don't want to send it to public cloud. Instead, you want to use a hospital cloud. And non-sensitive, you want to send it to public cloud. So how to do that? So they created a deep learning library, deep learning methods that can classify medical records into sensitive, non-sensitive, and you plugging that to Anika, they were able to do it. Like that, different applications by different people, including object detection, like a moving objects. If you have a camera, you keep looking at the moving object and detect what is that object type. So yeah, application. Then we also did on this COVID-19 research data analytics. So this is just in brief different application. Now just to show you one or two. So for example, from China. So this is a high-speed train design scenario. So you can see there are different train design scenarios, and they need to be analyzed to find out which is the best optimal that meets both economic requirement and also other requirements. So this kind of scenario analysis was they used to do on a 4-core server, using software called Maya. So this is a rendering application. So this application used to take something like 1 day to 4 days depending upon scenario. So to minimize that time, instead of waiting for 4 days, they want to get answer in 2 hours. What did they do? They set up a private cloud inside their organization, and they use our Anika Design Explorer, where they are able to express this application as a single program multiple data SPMD application and run it on a private cloud environment. By doing so, what used to take 4 days, like 24 hours to 80 hours, the same thing they were able to do it in 2 hours using 30 servers in the organization. Now, so you might say, okay, 2 hours is fine, but sometimes you have a urgency. You might want analytics done within 10 minutes. What do? The local resource takes 2 hours, but you want answer in 10 minutes. So this is where multi-cloud comes into picture. Within Anika, you can click on Design Explorer, set deadline is equal to 10 minutes. Now we want to use external cloud resource as well. But external cloud resources are provided by some commercial players like Alibaba or Microsoft or Azure or Amazon. So these providers charge different price to different capability. So within Anika, you set deadline equal 10 minutes, then you set budget. Budget is equal to 5 euros, right, in real work. So then Anika on your behalf looks into computational requirement, looks into services, their price. Then because you set a budget limit also, accordingly choose set of resources and combine them together in such a way that the computations are done, results are delivered within deadline of 10 minutes, budget of 5 euro. I think this makes even a lot more sense to our colleague who introduced me, last Jack, professor from economics domain. You can see. So we built this economic oriented resource management and application scheduling systems that operates in a real world style. So this is one example of application. So that is engineering. Now let me talk about this healthcare. So in case of healthcare these days with COVID-19, the big issue worldwide, monitoring how people are, if somebody is tested positive, so how is he doing in terms of his respiratory and so on. There are lots of issues. But anyway, this is the work that we have done wherein we are able to integrate sensing, mobility, and cloud. So there are various healthcare sensors like we work with our School of Electrical Engineering in Melbourne University, created a sensor. You can tie it to hand. The sensor collect the data, send it to mobile phone, and this data from mobile phone we can send it to a cloud where the actual processing is done. For example, EC data analytics. So here is the ECG analytics software which is built on top of Anika and running on Amazon. So here, of course, in case of ECG application, number of users, number of patients that are using this application can vary drastically. Initially, you might have 100 users. With over a period of time, you might have 10,000 users. Like this, number of users can increase and decrease. So Anika is able to allocate resource in such a way that the requirements of users are met. And of course, the users also, the patients, somebody in emergency, they might say, give me answer in 1 minute, and I'm happy to pay 10 euros. Somebody who is relaxed might say, okay, give me answer in 24 hours, but for that I'll only pay 10 cents. Correct? Like this, you define, then Anika is able to allocate resource to deliver answers as per the user requirement. So this is what we call market or advances in this area. We demonstrated this in many places. This work. Now you can see more and more real such things have already coming. Here we connected the sensor to person hand, and data collected sent to mobile phone to cloud, and results came back. And you can see this graph, whatever. So based on graph, you can say a lot about a person. So person health status, health condition, including even how many hours person has slept yesterday night. So like this, there are lots of interesting results can be presented by this integrated analysis of health data on cloud, and we use Anika to demonstrate it. So that was healthcare. Now coming to AI application. So this is what we call intelligent systems. So here is the deep learning based object detection. So with cameras deployed everywhere, especially during this COVID-19, this lockdown, government says, okay, people cannot walk around. Even right now here in Melbourne, from 9 p.m. onwards night, we are under a curfew. We can't go out. So we can only be at home. We can't go out. So, but if people may be walking around, you can't put a police everywhere. What can we do? Perhaps this camera there that are capturing images, then find out, is it a person or maybe some other animal? Correct? There might be some kangaroos running. You don't want to enforce those because animals are free to move. So anyway, this object detection. So here the camera that continuously capture the images, and you want to analyze to find out what is the object. So this is called object detection. This is where AI library comes into picture. So there are some ready-made libraries, called, for example, deep.py library. So some of people have built this Anika application where lots of images rapidly coming, and you want to analyze in a timely fashion. So this is where they are able to use Anika APIs to make it as a parallel or a distributed version of application. They're able to distribute their computations within private enterprise cloud and also to public clouds like Amazon Azure in a seamless manner. So we were able to put in practice in many places. For example, in computer centers in different universities. So these cameras are there. The cameras capturing images, and they're able to classify what is in the computer center and those labs. How many screens are there? How many keyboards are there? How many students are there? So dynamically, this is a demonstration. So deep learning. So this is the AI application that is demonstrated through Anika. So finally, this mining COVID research publication. During last 18 months, already I think in my opinion, more than 200,000 papers are published in the context of COVID. So these papers are coming from medical domain, coming from computer science people, coming from economics people, coming from social networking people. Different people have published different so many papers. 200,000 paper. We don't have time to go through. What can we do? So for example, you want to find out what is the progress on vaccine, which is better, what are the risk factors, what is the effectiveness of social distancing. So if you want to analyze and you want to rank those papers, so we looked at this, COVID-19 research data, that are already available as a BIB, and then we developed machine learning techniques and created that application in Anika and able to run in timely manner. Like if you try to run it on a laptop, it may take 3-4 hours to give you answer, but we can run it on a cloud and get answer in real time. So just like it should be as simple as searching for a information in web. So these are the some brief results that demonstrate the time it takes to analyze this data and present results. So if you do it on a one computer, it took something like 20 minutes. The same thing in just 4, you bring it to 5 minutes. So you maybe rent more, so you can bring down further. So this is illustrating the application of use of Anika in creating such application. So this Anika software is actually commercially available from this company manjasoft.com. I started as a spin-off company for Melbourne University. So right now we have got Anika 5.0. So with users all over the world, and of course not only all over the world, but in a country like India, so many people are using this Anika for teaching courses in cloud computing. So so many universities have set up Anika-based laboratory and they're able to teach. So this way, students that are graduated will come out with skills in application programming, how to cloud application programming. So this way they have good skills and then go on work for the real world industry. And here are the list of several universities in India who are teaching. So like that, some of the universities in Spain coming to Europe, Spanish universities are teaching. They've set up a cloud lab like that in Brazil, US. So many universities around the world are teaching courses, and Anika is being used. So that is a good thing about um, this technology. So that is in brief about cloud computing, some of the latest development and application. Now let us shift toward the next part. This is a bit more brief about IoT and edge computing. So this Internet of Things, as we all know, the IoT paradigm is about shifting from the traditional internet, which is networks of computers, towards networks of everything. So what are those everything? Everything can be the vehicles, the roads, and the cameras everywhere that deployed. Then the various kinds of sensors measuring pollution, measuring security, or even the moisture at the field. So this way you can create smart agriculture application, smart transport application, smart healthcare application. So this is going to be a big thing. By 2025, it is projected that it will be something like 10, $11 trillion economy. So therefore, it is very important for us to look into this area with so much of opportunity. And these IoTs, as I said, allows us to create smarter environments, healthcare in the cities, the logistic management in Industry 4.0. And we have so many of these applications. And these applications, when they become part of real world, they introduce a lot of challenges. So from that context, let's take a look at what application and technology paradigm we need. The traditionally all these IoT applications were cloud centric. So that was okay because there were only few IoT devices. When there are few IoT sensors are there, you can always push the request to the cloud where processing of data is done, results come back. But by 2025, we are saying billions of IoT sensors will be there. And if all the sensors capture the data and then push it to cloud, what happens? Internet get clogged. Then the application that is supporting these requests will not be experiencing too much of load. As a result, response time will be very high. So latency will be very high. So what to do? So in this case, the new computing paradigm that is called edge or fog computing, wherein rather than pushing all the requests to cloud, why don't we use resources at the edge of the network, our core networks? And then use the resources to support this application. And of course, whenever necessary, you also use cloud service. So this is the integration of edge resources and the cloud resources in seamless manner to deliver those capability to end users. So this is what this edge and fog computing is all about. And here pictorially, I demonstrated one is like pushing to the cloud, centralized cloud. Second, just using pure edge. The third, not only use pure edge, you might use just the core network resources. The fourth one, edge, the core network, and also cloud together. So generally pure edge, and then the fog is more a mix of edge and cloud. Of course, in today commercial domain, people interchange cloud and fog computing model interchangeably are used. It doesn't matter, but anyway, I just want to explain very clearly, purely what it is. So coming to this edge resource allocation and cloud resource allocation and support application, we developed one more new software framework called Fogbus. So this is a framework for creating ads or for computing application with blockchain. So here is high level key components of this our Fogbus. So where you see a gateway model, then the ads broker, resource broker, then you have various compute workers running Raspberry Pi, then the Azure is the public cloud. So the requests are captured by sensor like oximeter if it is healthcare, and then it comes to a mobile app where you have a healthcare app running on a mobile phone, and this mobile phone talks to a edge resources, and then of course that the broker managing the edge resource might also use a cloud resource as well. So this is the integration of edge cloud to support those applications. And we created many healthcare applications for example, sleep apnea analysis. So this oximeter available for just like a 20 euros. You can buy oximeter, connect to, you can just put it to your finger, and then data is collected. And then the oximeter through Bluetooth networking talks to an app running on mobile phone, and that app we built, which is called HealthKeeper app. And this app now can connect to a suitable edge or a cloud. Then and in that the background on the edge side and the cloud side, we have the sleep apnea analytics application, which is a service running. And then of course when the requests go there and processing is done, it just come back. So you can see just by capturing data for a few seconds and then processing, you can actually tell about person status in terms of severity. So that it is sleep apnea disease. Is it normal? Is it mild? Or is it severe? Based on the person health condition, we can quickly send him to hospital. So similarly, you can create numerous applications of this ECG for different purposes. Nowadays, with this COVID-19, when people have this breathing problem or COVID symptom, so they don't want everybody to come to hospital. Instead, you stay at the home. Then using this kind of sensor, data is captured and analyzed. Perhaps the processing is done at your own place. Then accordingly tell you what to do. So this is a model can be applied there. So we have deployed or demonstrated this also publicly many places. Here you can see Raspberry Pis and the oximeter, and we connected this oximeter with professor finger, and the data collected and then processed in the edge or a cloud. And here you can see the integration of oximeter, iPhone, then gateway machine, and the Raspberry Pis. Raspberry Pis, as you know, is like a matchbox size computer available for like something like 15 euros. So this kind of computers together, and they can be used in smart traffic environment, smart vehicular networking, and then using framework like this Fogbus. As I said, Fogbus also has a blockchain. So when you enable blockchain, for example, this data that is captured and processed and come back, and you might say, hey, somebody might have tampered this data, so I can't trust the result. What do? We can enable the blockchain. Within our framework, you just say blockchain is equal to true. Then the system, of course, uses blockchain to secure your transaction data movement, processing and results come back. So that is a good thing about it. So that was about practical implementation. Then, of course, we also developed a simulator. So the people who are doing research in fog edge computing, so they might be interested in a simulator. So we also developed a simulator called iFoxim. So this simulator provides all these capabilities in real world, but in the form of simulation models. You can simulate number of IoTs, you can simulate compute devices, you can simulate application, and based on that simulator, you can evaluate your new ideas. So this Foxim is used by users all over the world. So many users from different countries in Europe, in America, in South America, North America, and of course Asia, Australia. People are doing a lot of research. So for cloud computing, we had a Cloud Sim. For fog computing, so adds iFoxim. So these are different technological. This is my final application example, the drone-based network system for combating COVID-19 pandemic. So especially in places like, large population like in India, the cities with the multi-story building, people locked down, people are in the, different floors in the building. So you want to measure how the health of thousands of people living in that big building apartment. So here is a drone-based solution we did with one of the company in India. So the drones fitted with thermal camera is able to move around the building then people were asked to come to the balcony. So they measure the temperature. If somebody has a temperature which is symptom like a COVID-19, maybe you can quickly isolate that person. So this drone is able to capture the data. So you can say sensor, and the data is sent to a edge or a cloud environment where processing is done. And then of course hospitals can and the doctors can make a decision. So we have provided this as a initial framework that was done last year ago to demonstrate this concept. So you can see if you just search for this paper, you will find full details about how we did it. So this drone integrated environment for healthcare, pandemic context. So with that, let me conclude to summarize and summarize. So there are several computing paradigms have promised this vision of making computing as a utility. Okay, so this cloud computing is the one that turned this vision into reality. And then of course, many exciting applications of cloud we are using day-to-day basis, but many more to come. So you can expect AI driven and more advances in microservices will enable lots of smart applications as time progresses. So in 4 or 5 years time, it will be huge opportunity. Then in terms of software engineering, of course, software engineering is very complex. Building application that can easily scale seamlessly across multiple cloud is very complex thing. So to overcome that limitation, we have developed this Anika as a rapid application engineering platform. And once you build that application, you can deploy in a private and public cloud in a seamless manner. And we have demonstrated this use of Anika with many varieties of application. And today's, briefly I presented how we applied for engineering, how we applied for healthcare, and how we applied for AI application in the context of COVID-19 as well. And then coming to IoT, is rapidly driving new innovations in the field. The first generation IoTs were cloud centric, but now we are seeing a shift towards the second generation IoT application, which are mostly edge and IoT integrated. So that model is very important because we can support large number of requests with low latency by harnessing edge resources, not just cloud. And this way we can reduce the load on internet also as billions of IoTs are deployed. So if you want to learn more about cloud computing and how to use Anika for application programming, so here is a book. So this is Mastering Cloud Computing. So published in USA, American edition. So which is a bit costlier, something like $100 or maybe 80 euros. The same book available in India, for example, just for $10. Because in these Asian countries, they can't afford that $90 to buy a book. So perhaps make it $10. So the same thing that is published by a publisher based in India. Then if you want to make it available for Chinese, even for them that looks very expensive. So therefore we have a Chinese and a Chinese language just for $5. So you can see the differentiated pricing, the same content, but the content, the paper quality of the books is maybe different. Yeah. So like this, there are books on edge computing also. Okay. So you can see those from my website. Okay. So with this, let me stop here. And I guess I have left close to 10 minutes for any possible question answers. So here are, thank you for your attention. So I have mentioned my email IDs depending upon your interest. If you want to interact with me, collaborate or explore some research. So that is my Melbourne University email ID, rbuya@unimelb.edu.au. And if you want to create something commercial solution and make it available for the whole world consumption, and of course, we love to work with you. So my Manjurasoft email ID, raj@manjurasoft.com. Okay, so thank you.
Thank you very much, Raj, for very knowledgeable talk and for allowing, in fact, this few minutes for questions. So we can now take questions from the audience.
I have a question, honestly, about blockchain, because I'm not a specialist in blockchain, but as far as I know, they put the blockchain on the edge could be dangerous for, let's say, for these resources, because blockchain, as far as I know, it's very resource ineffective. I mean,
Yes.
So did you try in your work to use the blockchain, really use the blockchain? Did you do some more or less real world or close to real world application or test with blockchain.
Yes, so I agree with you. It introduces a lot of overhead when you use blockchain in service delivery. So coming to the conceptually, what is this blockchain? Essentially, so you have a like a chain of blocks: data block 1, data block 2, data block 3, data block 4, like these data blocks. So what does this block contain? The data, and then you encrypt, and then you give a link to the next one. So like this, the next one, like this next one. If somebody has tampered, that block is broken. So chain is broken. Therefore, you can say we can't trust this anymore. So we just created lightweight version of our own, wherein the data that are captured by like oximeter sensor, each of these data, each snapshot of data, we made a blocks and then encrypted it, then connect to the next one. And these data is what we send it to our edge or cloud processing environment, and it process and results come back. So now I check a block. So is there any break of this block? If there's a break, I can say somebody tampered it. If not, I can say results are trustable. So this is our own lightweight implementation. So this is not any, yeah. Then
So
if you apply it to.
So you send data to cloud to process them, and the blockchain
Yes.
only for controlling if this chain has been blocked or.
Correct, chain of data. So if imagine somebody when you are transferring data from your device at your finger to somewhere in the edge or a cloud, somewhere it's going. So you just want to make sure that nobody man in the middle has changed this data and the modified data sent to cloud and result process come back. So you don't want that kind of results. For example, people, if you really automated, if this, we collected some sample of a person, so e.g. COVID positive or negative. So if we such a data is sent, if somebody has tampered, then the results come back saying that COVID positive. Actually, it is negative, but result come back positive. So this can be very frightening to a person. Sometimes when people get frightened, they become weaker, and because of it, they might even die. Correct? May not be because of COVID, but because of frightening. So psychologically, person is weakened.
Okay.
Yeah. So our aim is to demonstrate that these are the things you can do. So we created lightweight version of ourselves. But if you apply it to this bitcoins or currency generation, then I can, yes, I agree with you. It consumes lots of computing capability. In fact, creating one Bitcoin is maybe on a computing system. It seems it's consuming energy almost equivalent to the Bitcoin value. So it is very expensive proposition. Yeah, but lightweight approach.
Do you have
Thank
an
you.
application with this lightweight approach? So just to prove.
Yes, so we demonstrated that healthcare, that sleep apnea
Healthcare.
application.
Okay.
Yeah,
Okay.
that is our case study. Yes.
Thank you. Thank you. Next question, please.
Okay, so I will unmute myself.
Dominic.
Dominic, so I will be first and then Dominic, okay?
Okay.
I just have a quick one, because nowadays it seems that there is a lot of interest in so-called federated learning. And my question is sort of, you didn't mention federated learning, but Raj, did you already look how to apply your well, not the cloud one, but the edge, the distributed infrastructure to support federated learning, or is it in your plans?
Of course, I haven't done explicitly, but if there are people who are working on like multi-agent frameworks, so and then if that framework requires the deployment of those agent computation across multiple places, and then assuming that data is available in different places, so we can actually support such application. But I haven't done myself such a explicit federated learning framework. Something can be done on top of Anika, for example.
Yeah, this is, I was just checking because I haven't seen the federated learning as the bullet in your slides, and it seems that with the edge and fog or whatever, extended edge and edge computing, there is a lot of need that is going to materialize to do some form of federated learning or maybe multi-cloud environments in which the key aspect is the privacy of local data, and then you need to provide an infrastructure to share it. So, but this was just a generic question. Dominic,
yeah, I know, it's a good one. I'll think about it. We'll exchange emails. Maybe
okay,
we'll do it together.
Dominic, you had a question.
Thank you. Thank you for great lecture. Very informative. Maybe my question is slightly related to Marcin's question, because again, it is about learning, about AI and machine learning. So in AI, in machine learning, there are several steps, several phases, or sometimes this is like endless phase in some kind of loop, like first learning, then applying, but somehow in the meantime, maybe improving the model, or maybe active learning, various combinations. And on the other hand, we have cloud, we have edge, we have fog. So I would like to ask you about your impressions. How to design this process of machine learning usually? Like, I don't know, my naive assumption would be that I need first to learn the model in the cloud, because it needs a lot of computational power and a lot of data together somehow. But then once it is already trained, I can put it close to the edge, right? So it works remotely very efficiently. But maybe there are some other scenarios. So what is your perspective about it?
Yeah, so what I see is people are doing model training. So pre-trained models are there, and then after that you can use the trained model in analyzing the next set of data that are coming in. So yes, model training is a big operation, and people have shown that model training can take substantial time and compute capability. Yes, if it is the edge, of course, because edge would have very lightweight devices. So certainly that model need to be trained and transported to the edge. Then on you can use it. So that is one of the way of doing, which is sort of we can say federated learning, wherein model training is done somewhere else, and then you get the trained snapshot and use that model for the rest of the one. Otherwise, you can't really train that model in each and every place. And even if you train with little data, it won't be efficient at all.
Thank you very much.
Thank you. Thank you. More questions? I think we can still afford one or two.
I am afraid that we already have no time for questions, so I would like to suggest the rest who didn't have time to ask their question to write to Raj.
So I would like to thank you, Raj, for excellent talk. Thanks for coming to Sofia for that. And we hope you can come in person next year. And in the meantime, so thank you.
Thank you very much for having me.